Hello students, and welcome to this module of home tutors. In this module I will be discussing simultaneous equations. Your facilitator is still Kayode Babatope. And in this module we'll be looking at the following outlines. We'll be looking at the definitions of simultaneous equations, the general representations of simultaneous equations. We will be looking at the methods of solutions, and we'll be looking at three different methods of solutions of simultaneous equations. We will be looking at elimination method, we will be looking at substitution method, we will be looking at graphical method. Then we will look at word problems leading to simultaneous equations and how to solve them. And lastly, we'll treat a lot of past questions. Definition of equations. In general, equations are defined depending on the highest power of the variables. An equation is a collection of algebraic terms linked by mathematical signs and an equality sign. For example, 2a is an algebraic term. 3 is also a term, although specifically called a constant because it has no variable associated with it. If we link them by an addition sign, for example, we will have 2a plus 3. This gives an expression. 2a plus 3 is an expression. But if we then introduce an equality sign, say 2a plus 3 equals to 8, this then becomes an equation. So you see now what we said earlier, that an equation is a collection of algebraic terms linked by mathematical sign and an equality sign. 2a is an algebraic term, 3 is an algebraic term, although most appropriately called a constant because it has no variable associated with it. This is a mathematical sign, okay? And then 2a plus 3, that is a mathematical sign linking algebraic terms, gives an expression. So when an equality sign is introduced, it becomes an equation. In the above equation we just looked at, the variable is a and it has a power of 1, so it is actually called a linear equation because the highest order of the variable is 1. The name linear stemming from the fact that when this equation is plotted on a graph, it will give a straight line plot. Other forms of equations also exist, being named according to the highest power of their variables. For example, x squared plus 5x plus 9. This is a collection of algebraic terms linked together by mathematical sign together with an equality sign. So this is an equation in x, but then the highest power of the variable is 2, and these kind of equations are called quadratic equation. Another example is y cubed plus 3y squared plus y minus 6 is equal to 8. This is a cubic equation because the highest power of the variable y is 3. Also, we have z raised to power 4 plus 4z squared plus 6z plus 7 equals to 0. This is called a quadratic equation since the highest power of the variable z is 4. Finding solutions to linear equations is not so difficult so long as it has one variable. The solution to the equation is the value of the variable that makes the equation to be true. For example, consider the equation a minus 6 is equal to 8. This gives a is equal to 14, which is true since 14 minus 6 will give us 8 as given by the equation. So normally we would say a equals to 14 satisfies the equation, or we can also say a equals to 14 is the solution to the equation. However, when we have linear equations in two variables, like say 2m plus 3n equals to 7, The solution of this is not as easy as that of the above, which has just one variable. In fact, to get a solution to the equation, a linear equation in two variables, another equation of the same sort is needed, and the values of the variables will be true for both equations. For this reason, we say the two equations are called simultaneous, hence the name simultaneous equations. So we see the origin of simultaneous equations. In order to solve a linear equation in just one variable, it's quite easy to solve. Like we see here, a minus 6 equals to 8. It's easy to solve for a. However, if we have a linear equation in two variables, for example, 2m plus 3n equals to 7, this equation cannot be easily solved alone. It's not even possible to solve this equation alone. So, in order to solve for the values of m and n in this equation, we need another equation in m and n. And therefore, these two equations, both of which are in m and n variables, will now be solved together simultaneously. And the values of m and n that should be correct must be valid for both equations. There are four basic methods of solution of simultaneous equation. They are the elimination method, the substitution method, the matrix or determinant method, but the matrix or determinant method will not be treated in this module. It will be reserved for an advanced module on quadratic equation. And then we will also discuss in this module the graphical method. Elimination method. A pair of simultaneous equation will be given as below. 3s plus 2t equals to 5, equation 1. 5s minus t equals to 4, equation 2. So we can see that each equation is linear and it contains two variables s and t. So we have been given two of them to solve simultaneously for the values of s and t. How does the elimination method work? The task here is to find values for s and t that holds true for both equations. By careful inspection, it could be noticed that if s equals to 1 and t equals to 1, both equations would be satisfied. But mathematics requires working out and not just careful deductions. And this is what the elimination method lends us in solving problems like this. The idea is that since there are two variables whose values are unknown, then if one of these variables is eliminated, we can get the other as the resulting equation would be a linear equation with one variable. Rules for elimination. Check the coefficients of the variables in both equations. 2. Choose a variable to eliminate. This is because since you have an equation in two variables, you can write the equation in terms of one of the variables. So choose a variable to eliminate by rewriting the equation in terms of that variable to be eliminated. 3. If the coefficients of the variables are equal, then you can either 1. Multiply equation 1 by the coefficient of the variable to be eliminated in equation 2, or 2. Multiply equation 2 by the coefficient of the variable to be eliminated in equation 1. 4. Add or subtract the resulting equations in a way that eliminates the variable you intend to eliminate. 5. The resulting equation after step 4 will be a linear equation in just one variable and can be solved for that variable. And 6. The above steps is repeated to get the other variable. For example, solve x plus y equals to 6 and 2x plus 3y equal to 14. Now let x plus y equal to 6 be equation 1 and 2x plus 3y equals to 14 be equation 2. Now, let us choose to eliminate x. According to the procedure we saw earlier, the coefficient of x in equation 1 is 1, while that of x in equation 2 is 2. Therefore, multiply equation 1 by 2, okay? Multiply equation 1 by the coefficient of x in equation 2. Why? Because we have decided to eliminate x. And that gives us 2 into x plus y equals to 2 times 6. That gives us equation 3. And also multiply equation 2 by the coefficient of x in equation 1. While we are doing this is to be able to make the coefficient of x in both equation 1 and 2 to be equal. Okay? So by the time we also do that, we will have 1 into 2x plus 3y equals to y into 14. You can see now that you now have 2x plus 2y equals to 12 from equation 3 and 2x plus 3y equals to 14 from equation 4. Now you can see that the coefficient of x in equation 1 and the coefficient of x in equation 2 are equal. So now, if you subtract equation 3 from equation 4, x will disappear from the expression and you will have a linear equation only in one variable, y. I hope you understand that. Now, equation 4 minus equation 3 now gives 2x plus 3y minus 2x minus 2y equals to 14 minus 12. What does that give us? 2x minus 2x cancels out. We have 3y minus 2y. That gives us y equals to 14 minus 2, and that gives us y equals to 2. Is that not interesting? So that is how the elimination method works. You decide which variable to eliminate. You could also have decided to eliminate y. The only difference will have been, if you intended to eliminate y, you will have had to multiply equation 1 by 3. Okay, so that now here we will have 3y, and then multiply equation 2 by 1. So by the time you subtract the equations, 3y will cancel out 3y, and then you will have an expression simply in x. That is what we just saw here. To eliminate y, you have to multiply equation 1 by 3 and multiply equation 2 by 1. And that will give you an expression in x. And from there, you can calculate x equals to 4. As you already calculated from here, y equals to 2. So this is how the elimination method works. Decide which variable to eliminate, and then multiply the equations appropriately in such a way that the coefficients of the variable you want to eliminate become identical. Therefore, the solutions to the equations are x equals to 4 and y equal to 2. Example 2. Solve. 7 into a plus b equals to b minus a, and 4 into 3a plus 2b equals to b minus 8. Our first task is to try and write the equations properly in such a way that we have variables on one side of the equation and we have the constants on the other side of the equation. 7 into a plus b equals to b minus a. This can be rewritten as 7a plus 7b equals to b minus a. And further, if you collect like terms, you'll have 7a plus 7b minus b equal to 0. And that gives us 8a plus 6b equals to 0. So this is our equation 1. So this expression can be rewritten as this equation. Also, 4 into 3a plus 2b is equal to b minus 8. If we expand, we have 12a plus 8b is equal to b minus 8. If we then collect like terms, we have 12a plus 8b minus 8b is equal to minus 8. And that finally gives us 12a plus 7b is equal to minus 8. And that gives us our equation 2. So this expression can be written in terms of this equation. So therefore, the question becomes 8a plus 6b equals to 0, equation 1, and 12a plus 7b equals to minus 8, equation 2. So these are the two equations we need to solve simultaneously. Now, let us decide to eliminate a from the equations so that we can get a linear equation in b. All we need to do is to try and make the coefficients of a in both equations identical. How do we do that? All we need to do is to multiply equation 1 by 12 and then multiply equation 2 by 8. So by the time you multiply equation 1 by 12, you will have 96a, and by the time you multiply equation 2 by 8, you will also have 96a. And then by the time you subtract the two equations, you can knock out the variable a. Alright, so multiply equation 1 by the coefficient of a in equation 2, that is, multiply equation 1 by 12. So you have this. 12 into 8a plus 6b equals to 12 times 0. That gives us equation 3. And also multiply equation 2 by the coefficient of a in equation 1. That gives us 8 into 12a plus 7b equals to 8 times minus 8, and that's our equation 4. So if we expand the equations, we have 96a plus 72b equals to 0. If we expand that to equation 3, we arrive at this. And if you do the same thing to equation 4, we'll have 96a plus 56b equals to minus 64. Okay, so looking at equations 3 and 4, if you subtract the equations, you will be able to knock out a because the coefficients are now equal. So let's do equation 3 minus equation 4. That gives us 96a minus 96a plus 72b minus 56b is equal to 0 minus 64. Okay, because we are doing equation 3 minus equation 4. So we are going to have 0 minus 64. That gives us 0 plus 64, which is 64. So from here, we can knock out a. 96a minus 96a is 0. 72b minus 56b will give us 16b. So therefore, 16b equals to 64. That will give us b equals to 64 over 16, which is equal to 4. Okay? However, there are two ways you can proceed after this point. You can go back to this set of equations and resolve the equation with the intention of eliminating b. In this case, in order to eliminate b from this equation, all you need to do is to multiply equation 1 through by 7 and then multiply equation 2 through by 6. Okay, by the time you do that, you will be able to knock out b and just solve for a exactly. However, the second approach is to go into any of the equations. Now that you have been able to calculate the value of one of the variables, you can use substitution method to calculate the value of the other variable. From equation 1, and you can use any of the equations. From equation 1, 8a plus 6b equals to 0. Now you already know the value of b, that b equals to 4. So 8a should be equals to minus 6b. Okay, but b has been calculated to be equal to 4. Therefore 8a will be equal to minus 6 times 4, which is minus 24. So therefore a will be equal to minus 24 divided by 8, which equal to minus 3. If you use equation 2 also, you will still arrive at the same value of a. Use equation 3 or use equation 4, you will arrive at the same value of a. Any of the equations can be used. Once you have calculated the value of one of the variables, you can use any of the equations to calculate the value of the second variable. However, if you want to do strictly elimination method, you just come back to this set of equations and instead of eliminating a like you did in this procedure, try to eliminate b by multiplying equation 1 by 7 and multiplying equation 2 by 6. You will convince yourself that you will obtain a value of a equals to minus 3.